Isolate the radical. Well, the radical has a minus 3, so I need to move the minus 3 over where the x is. So this is an x plus 3 equals the radical. Once the radical's by himself, I can kill him by squaring him. Now, this is where you have to be very, very careful. Right-hand side's easy because you're just removing the radical. But this is not x squared plus 9. If you remember, this is x plus 3 times x plus 3. I bring that up because even my college algebras have that problem. So I need to FOIL that. So this is x squared plus 3x plus 3x is 6x plus 9. It's a quadratic, so you have everything on one side, 0 on the other. So x squared, subtract 3x, subtract 7, subtract 3x, you're going to get a plus 3x, right? And then subtract 7, you're going to get a plus 2. And then you're going to have 0 over here. And this factors into x minus 2, x minus 1, plus 1. Oh, come on, Peterson. So that x is negative 2, x is negative 1. So I can't reject a solution just because it's negative. Can't do it. I have to check it out. Maybe it works. So, suppose x equals negative 2. Is it true that negative 2 equals the square root? Because remember, the original equation is x equals the square root of 3x plus 7 minus 3. So it's 3 times negative 2 plus 7, subtract 3. Well, this is the square root of minus 6 plus 7, which is 1 minus 3, which is 1 minus 3, and 1 minus 3 is negative 2. So negative 2 checks. So you can't reject a solution just because it's negative. So if x equals negative 1, is it true that that negative 1 equals the square root of 3 times negative 1 plus 7, subtract 3, which is the square root of negative 3 plus 7, which is 4, subtract 3. Square root of 4 is 2, subtract 3. 2 subtract 3 is negative 1, and it checks. Both of them check. So I have 2 answers. Negative 2 and negative 1.